In the popular imagination, the space between planets is a vacuum, an empty stage where gravity is a simple, relentless downward pull toward the nearest mass. But to an astrophysicist, space is not empty. It is a complex, invisible landscape of peaks and valleys carved by the interaction of celestial giants. In 1772, the mathematician Joseph-Louis Lagrange solved a puzzle that Newton had left unfinished. He discovered 5 specific coordinates where the gravitational forces of 2 large bodies, like the Sun and the Earth, and the centrifugal force felt by a smaller object cancel each other out. These are not just coordinates, they are the parking spots of the solar system, the silent anchors where the chaos of the cosmos finds a momentary perfect stillness. The first 3 Lagrange points, L1, L2, and L3, exist along the line connecting the 2 large masses. They are technically unstable equilibrium points. Think of them like placing a marble on the very peak of a mountain. It can stay there, but the slightest nudge will send it rolling down into a gravity well. L1 sits approximately 1.5 million kilometers from Earth, directly facing the Sun. It is our solar sentinel point because it stays fixed relative to the Earth. Spacecraft like SOHO can watch the Sun 24 hours a day, providing us with early warnings of solar flares that could cripple our power grids. L2 is the jewel of modern astronomy. Positioned on the opposite side of Earth from the Sun, it sits in a perpetual shadow. It is here, a million miles away, that the James Webb Space Telescope resides, away from the heat and light of the Earth and Moon. It can peer into the infrared whispers of the first galaxies born after the Big Bang. And then there is L3, the hidden point, located on the far side of the Sun, always obscured from our view by the solar disk. While it has limited practical use today, it remains a fascinating mathematical ghost, a place where a counter-Earth was once hypothesized, though we now know the point is far too unstable to hold a planet. While L1 through L3 are like balancing on a needle, L4 and L5 are the islands of stability. These points are located 60 degrees ahead and 60 degrees behind the planet in its orbit. In a rotating frame of reference, these points act like gravitational basins. Anything that wanders into them tends to get trapped. We call these the Trojan points. Look at Jupiter. It is the undisputed king of these anchors. Trapped within its L4 and L5 points are thousands of asteroids known as the Trojans. These are not just rocks. They are pristine time capsules, remnants of the primordial disk from which our planets formed 4.5 billion years ago. By staying locked in these points, these asteroids have avoided collisions and planetary ejections for eons, waiting for us to come and read the history of our origin written in their craters. The true value of these points lies in our future. For a civilization looking to expand beyond its home planet, the Lagrange points are the natural harbors of the deep. Because an object at a Lagrange point stays fixed relative to the Earth and Moon, it requires minimal fuel to maintain its position. Only tiny, station-keeping burns. This makes them the perfect locations for orbital fuel depots, where spacecraft can refuel before a long-haul journey to Mars. The L5 point in particular has long been the dream of space visionaries. Because of its stability, it could host massive, rotating habitats. Cities in the sky where gravity is manufactured by spin, and the view is a permanent, unchanging Earth. We are moving away from the era of launch and return and into the era of stay and build. The Lagrange points are the foundation stones of that architecture. When Joseph-Louis Lagrange put pen to paper in the 18th century, he could not have imagined that his equations would one day guide a golden mirrored telescope to the edge of time. But gravity is patient, and its laws are absolute. We are no longer just passengers on a rock flying through a void. We are becoming navigators of the invisible. We have found the anchors. We have mapped the ridges. The parking spots of the solar system are open. The question is, what will we park there next?